Hello friends, this is Lakshmipati and now we are going to discuss about the hardening process. First of all, hardness is the mechanical property of material in which it resists the indentations of another abrasive materials. And this property, the hardness property, can be increased by the process called hardening, in which the material is heated from to austenitic temperature and quenched in a oil bath or some water with some other solutions. After a hardening process, the microstructure produced will be martensite in nature. Steel is heated between 725 degrees to 900 degrees centigrades, and this is called heating process. The heated steel is held at this temperature for a period of time to allow complete austenite formation, and this duration is called soaking process. Steel is allowed to cool in water bath or oil bath to the room temperature, and this is called the cooling process. And uh, what the purpose of hardening is already said that to improve the property, the mechanical property hardness, and to improve the wear resistance, ability to cut the other materials, and improve the strength and toughness. The application of hardness or hardening process is that these materials can be used as cutting tools and machine parts where high hardness and wear resistance are important. So the most of the tools which we are using in the lathe machines or any other machines are made up of or selected from the materials with high hardness, and the factors affecting hardness are the carbon content, quenching medium, and specimen size. Types of hardenings: the hardenings are work or strain hardening, age or precipitation hardening, air hardening, hardening by heating and quenching often. And CCR, the critical cooling rate, the slowest rate of cooling of austenite that will occur in 100% master dry transformation is called critical cooling rate. Hardenability determines the depth and distribution of hardness in material induced by quenching from austenite condition. Hardness are measured by Brinell, Rockwell, and Vickers hardness tests. And factors affecting hardenability: the steel composition, austenitic grain size, and steel structure before quenching, quenching medium, and methods of quenching. And about the Jomini and quench test or the hardenability quench test, universally adopted test, easy to perform, gives us usefully information to the designer or manufacturer, and which let us know the hardness property of different materials. And the experiment setup will be very much simple and easier and can be done in quickly. The and here's the specimen preparation steps and the setup diagram, and here's the final diagram that the hardness of the material will be increasing to the quenched end. And next, now discuss about the tempering process. The martensite, which is formed during the hardening process. In the hardening process, too brittle and lack ductility and toughness. Hence, it cannot be used for any applications. Internal stresses are induced during hardening. The ductility can be promoted. Internal stresses can be relieved by reheating temperature, produced called tempering. The main objective of tempering are the improved ductility, toughness, reduce the brittleness or hardened steel, remove the internal stresses caused during rapid cooling, and improve the wear resistance. The hardened steel will be heated from 150 degrees to 600 degrees centigrades for a specific period of time and air cooled slowly to room temperature. Carbon atom diffuses outside and cementite will be formed while VB will be in soft nature. As temperature increases, there will be increase in tensile strength and ductility. And the tempering process is a most common process followed after the hardening process to remove the internal stresses induced and the hardness which can be regulated using the tempering process. And types of tempering process are low tempering process, which would be occur at low temperatures from 150 degrees to 250 degrees range, and cooled slowly relieves the internal stresses and retain the hard microstructure of martensite. Applicable to cutting tools like high carbon steel and low alloy steels. Components made with this tempering are not applicable for impact loads. And medium temperature tempering, 350 degrees to 450 degrees range, and Clolis and slowly cooled. Martensite is transformed to trusite structure. A combination of medium coarse ferrite and cementite occur at 400 degrees centigrade. Steel becomes ductile and hardness is reduced. Medium strength will be maintained. Used in steel springs and coils. High temperature tampering, the range will be high comparative to the remaining, that it is from 500 degrees to 650 degrees centigrades and cooled slowly. Sorbite structure is formed. Medium coarse grain structure is formed, which is ferrite and cementite. Internal stresses are revealed, that is relieved, and strength toughness are improved with ductility. Applications are gear wheel, axial shafts and connecting rods. Stampering is a heat treatment process of medium carbon steel which produces a metallurgical structure called bainite. And it is also used to increase the strength, hardness, toughness. It reduces the distortion and resistance to shock, avoid internal residual stresses caused during quenching. Heating is done usually from 700 degrees to 950 degrees centigrades, and quenching at a constant temperature, usually range of 260 degrees centigrades to 370 degrees centigrades, maintained for a period of time. Held for a time for air cooling to allow transformation to a bainite microstructure, cooled to room temperature, and finally it is cooled to the room temperature. And here's the diagram for the Oss tampering. Tampering is a form of heat treatment applied as an interpreted quench of medium carbon steels, typically in molten salt bath at a temperature right above the martensite start temperature. The purpose is to delay the cooling for a length of time to equalize the temperature throughout the piece. This will minimize the distortion, cracking, and residual stresses. Benefit: reduces the cracking due to the thermal stresses, reduces the residual stresses in the quenched part. And here is the diagram of the Mart tempering. And let's go to the surface hardening methods. Surface hardening methods or case hardening methods. It is a process of hardening the surface of a metal object while allowing the metal deeper underneath to remain soft, thus following a thin layer of hardened metal at the surface. In all these methods, case depth depends upon the time and temperature. And here are the types, there are different processes and different methods, and one of the method is carburizing, solid or pack carburizing, liquid and gas carburizing. Solid carburizing. Components are packed into steel box with carburizing plus energizing mixture. 40 to 70% of charcoal, 20 to 25% brine carbonate, 3 to 12% of sodium carbonate and calcium carbonate. The process is done at closed environment to heated up to 700 degrees to 900 degrees centigrades between 6 to 72 hours. The maximum of 1.25 mm case depth thickness is obtained. And it is the setup of the solid or pack carburizing where it is sealed and the charcoal is placed over there and prime carbonate, and heat is applied and the hardening is done over the surface. Merits of the case solid carburizing is that simple process, carburizing materials cheaply available, low cost, inexpensive. Demerits: the insufficient heating temperature is not uniform, difficulty in handling carbon ash, process is not applicable for continuous operation, special cleaning required for the specimen as well as steel container due to ash. Liquid carburizing, salt bath containing 20 to 50% sodium carbonate and heated from 700 to 900 degrees centigrades, and it takes 30 to 60 minutes. Case depth of 0.5 mm thickness is obtained. Applications and merits: the temperature of heating is uniform. Components in bulk order can be treated together by immersing into salt bath. Cycle time is shorter, 60 to 20 to 40 minutes. Demerits: salt sticking to the component requires special cleaning processes. Gas carburizing, ethane or methane, 700 to 900 degrees centigrades and takes around 4 to 60 hours. The components are roasted in the furnace. A minimum of 0.7 to 0.8 mm thickness is obtained. Mass production of thin materials. It is the merits in this gas carburizing. Demerits: carrying of gas cylinders and maintenance, time consuming process. And in surface or case hardening, we have another processes like nitriding process, and we also have the same like liquid, gas, and plasma, which is like a semi-solid structure, and cyaniding and carbonizing. And the rest, another type of surface or case hardening is that the thermal process, thermal flame or induction and hardening. It is a hardening process which in with the combustible glass frame as source of heat for austenizing. The surface to be hardened is to heat it to a temperature about upper critical temperature by oxyethylene flame, which is applied by oxygen and ethylene gas. Then the workpiece is quenched by a jet of water in order to improve the hardness, and a maximum case depth of 3 mm thickness is obtained during the case of thermal or flame hardening. And let's conclude our video, and thank you.